In this video, I'm going to talk about visual organization. So how you sort of understand the stuff in your vision. And we're going to talk about depth perception as well as grouping. And I'm going to try to do a couple experiments with you, see if this works. But we'll try. I think your book also has a lot of examples of this as well. One thing to think about with visual organization is grouping. Grouping is basically how you put stuff together in your mind so it makes sense. We like to group or group things into meaningful units based on something they have in common. So it's the perceptual tendency to organize stimuli into meaningful groups. For the purposes of your test, there are 3 types of grouping that I think you should know about. You should know about proximity, you should know about continuity, and you should know about closure. So proximity basically says that things that are nearby get grouped together. For example, actually I'll define all 3 and then I'll do the example. That'll be slightly easier. Continuity says that we like to see smooth, continuous lines. We don't like discontinuous things. And then finally, closure says we like to fill in the gaps for things. So for my example of proximity, I'm going to do some drawing for you. If you have 3 lines or 4 lines like this, chances are in your mind you are grouping these 2 together and these 2 together. You are not seeing them as 4 complete lines. You're seeing it as 2 and 2. If you moved it like that, you'd see it, as 4 lines and then 1 line. So when things are near each other, you assume they go together versus when they are far away, like that. That's proximity. For continuity, you like to see continuous lines. A good example of this is if you have like an X, draw an X on the side of your notes. Chances are when you drew that X, you did it by, I'm actually gonna draw here, going like that. You did not go like that. You did not draw it like that because you like continuous lines. You perceive this as 2 straight lines versus funky angles. That's continuity. And then finally, closure, you like to fill in the gaps. So if I draw this, chances are you are perceiving a triangle right there. It's not legitimately a triangle, but in your mind, you are filling in the gaps. You like to see it more like that. You don't like to see it like that. So that one is closure. So those are 3 forms of grouping that you should know. And then finally, you should know about depth perception. So I'm going to clear this off so we can talk about depth perception. So for depth perception, what that is it's the ability to see in 3D. You are not born with this. This is something that has to develop. You tend to get it, well, you first start to show signs of it potentially as early as 8 months. You kind of have to relearn it when you start walking again. So definitely by a little after a year, you are starting to show strong signs of depth perception. The way we measure depth perception is through something called the visual cliff. This is potentially what the visual cliff looks like. It's a table with a plexiglass top and then a checker pattern over half of it. And you stick a kid, you stick a kid right at that ledge. So if you look, it looks like a cliff, but it's not really one. The kid's not actually going to like fall and hurt himself. But you put a kid here, and if they don't have depth perception, like when you put a kid here, 6, 7 months, they will just truck it right over that visual cliff because for them it doesn't look like a drop. They don't perceive depth in that way. At about 8 months, they'll start to pause there, like, this doesn't quite look safe. When they first start walking, again, they have to relearn depth perception when they start walking. So when they first start being able to toddle across, again, they'll just go right for it. They won't pause because they can't perceive that depth standing. And then after they've been walking for a couple of months, they'll pause again here. So that is the visual cliff. And this, even if you as an adult were put here on this edge, you would pause even if you know for sure that it's plexiglass, you're not going to fall. It's still going to make you hesitate. It's similar to, they have something like this at the Grand Canyon where it's a plexiglass walkway. In the Sears Tower in Chicago, on one of the top floors, they also have a plexiglass balcony that you can stand on. It will freak you out as you stand on that, even though you know you're not going to fall, because it still is perceiving that depth. So that is depth perception. Visual cliff is how we measure it. And there are cues that help you perceive depth. So we're going to go into those cues. Some of these cues involve two eyes. Those are called binocular cues. So you have to have two eyes to tell depth. There is a couple of binocular cues, just one really that you need to know, retinal disparity. Retinal disparity basically says your brain compares the images on each retina, and the differences in those two images help you perceive depth. Your book defines it as basically the greater the retinal disparity, the closer the object. So one way you can test this on yourself is if you stick your pointer finger up and you hold it straight out. So your arm is straight and you stare at your finger with both your eyes, because binocular cues, you got to use both eyes to do this. And then close one eye and stare at your finger and compare it to something in the background. And then close your other eye instead and look and see how your finger jumps basically across your visual field, and then move the finger right in front of your face and do the same thing. Close one eye and look at it, and then close the other eye and look at it. And when the finger is right next to your face, it jumps a lot more. There's a bigger difference in where it is in your visual field when it's really close, because closer objects mean a greater disparity. So that is the binocular cue you need to know. Again, there's another one like how cross-eyed you are. It's called convergence, but we're not going to go into that one. It would not be on your test. The other type of cue you need to know are monocular cues. And monocular cues are ones that involve one eye. You only need one eye. And there are 4 that I want you to know. We have relative size, inner position, linear perspective, and relative height. So I'm going to go over these by doing examples. Relative size says that when something is tiny, we assume it's farther away. And I am going to draw some fairly ugly stick figures for you to help show this to you. So if you have 2 stick figures, and one is this size, and one is this size, chances are when you look at them, it looks like this dude is farther away. That would be relative size. You know this general size that they're supposed to be, and so the tinier one must be farther. If you see a really, really, really small elephant, you don't think, wow, that's a tiny elephant. You think that elephant is far away. If you see a huge grasshopper on your windshield, you assume it is right near your face. You don't assume it just happens to be a monstrous grasshopper. That is relative size. Inner position is real easy. Basically, if one thing is blocking something else, the thing being blocked is farther away. If you're sitting behind a table so that the table is blocking your legs, most people would assume the table is in front of you, and that's why they can't see your legs. That's inner position. So you look at what is blocking something else. Linear perspective says that in the distance, parallel lines converge. So the whole thing with parallel lines is that they aren't actually supposed to come together. But if you have something like this, like, we'll make it train tracks. chances are if you look at this, it kind of looks, I'm assuming, that it goes towards the distance. So it's heading towards the distance that way. We'll fix that weird looking one. That is linear perspective. Parallel lines seem to come together in the distance. And then finally, relative height says that the higher something is, the farther away it appears. So even this would be an example. This dude is higher than that dude. A better example, I'll draw some trees. So if you have some trees, I'll draw 2 of them. The one that's taller or higher is going to look farther away. So chances are this guy appears farther away than this guy. You can combine that with the relative size. So if I switch this one and make him a lot bigger, it'll be more obvious. So if I make him a huge tree, and remember I am a psychologist, not your art instructor, chances are this one appears close, this one appears far away. If you switch this, if you confuse relative height and relative size, it's really going to screw with you. I will show you what that looks like. So if you, using linear perspective to help, switch up relative height, so the taller thing, the bigger thing is also the higher up, you really don't perceive this as farther away because the relative height is confusing you. However, if you combine these 3, relative size, linear perspective, and relative height, it will be very obvious in your mind which one should appear farther away. So now when you have all 3 of these working together, you've got your relative size. This one, the closer one, is bigger. You have relative height. The higher one is supposed to be farther away. And then you have the linear perspective. These lines are coming together. In your mind, you can really kind of see this as train tracks going back into the distance. You can really perceive that depth. So this is how you would use monocular cues to help you tell how far away something is, and that is in contrast to binocular cues.